NEC 210.52b addresses kitchen outlet requirements, stating that in kitchens, a minimum of 220 amp small appliance branch circuit shall be provided for kitchen counter outlets. There are exceptions. Firstly, counter outlets supplied by a cord and plug connection to the receptacle outlet for the electric range, oven, or countertop cooking unit. Secondly, a portion of the counter surface that is less than 3 feet in length and that has no small appliance outlets served by a single branch circuit. And thirdly, countertop space is occupied by built-in dishwashers, trash compactors, refrigerators, freezers, and ranges. The text of the NEC does not require dining room outlets to be on the appliance circuit, but it does allow it as an exception. A local electrical inspector may have interpreted the code to require dining room outlets to be on the appliance circuit in a specific jurisdiction. It's important to understand the context and intent behind these electrical codes to ensure safe and compliant installations. Let's break down the key aspects. Firstly, the purpose of small appliance branch circuits. Secondly, the scope of NEC 210.52b, and thirdly, how local interpretations can influence the application of the code. Small appliance branch circuits are designed to supply power to small appliances typically used in kitchens. These circuits are rated at 20 amps to accommodate the load for multiple appliances operating simultaneously. The NEC specifies that at least 2 such circuits are required for kitchen counter outlets to prevent overloading and ensure safety. NEC 210.52b specifically focuses on kitchen counter outlets, outlining the minimum requirements for small appliance branch circuits. The exceptions listed in the code provide flexibility for certain situations, such as when counter space is limited or when appliances are permanently installed. These exceptions are intended to address practical considerations while still maintaining a safe electrical system. Local electrical inspectors play a crucial role in interpreting and enforcing the NEC. Their interpretations can vary based on local conditions, amendments to the code, or specific requirements in a given jurisdiction. It is essential to consult with a local electrical inspector to understand their interpretation of the code and ensure compliance. In this context, the question arises whether dining room outlets are required to be on the appliance circuit. According to the NEC, it is not a general requirement. However, local electrical codes or interpretations may vary, making it essential to consult with the local electrical inspector for specific requirements in the area. The NEC serves as a comprehensive guide for safe electrical installations, but its interpretation and enforcement can vary depending on local circumstances. By understanding the purpose and scope of specific code sections and consulting with local authorities, electrical professionals can ensure compliance and promote electrical safety. Let's delve deeper into understanding branch circuits, especially small appliance branch circuits and their significance. Branch circuits are the portion of an electrical system that extends from the last overcurrent protective device, such as the circuit breaker or fuse, to the outlets that supply power to appliances and equipment. They are designed to distribute electrical power safely and efficiently throughout a building. Branch circuits are classified based on their amperage rating, which indicates the maximum amount of current they can safely carry. Common branch circuit ratings include 15 amps, 20 amps, 30 amps, and 50 amps. The appropriate rating for a branch circuit depends on the type and number of loads it will serve. Small appliance branch circuits are specifically designed to supply power to small appliances, typically in kitchens. These circuits are rated at 20 amps and are required to serve counter outlets in kitchens. The purpose of small appliance branch circuits is to provide sufficient power for multiple appliances operating simultaneously, such as toasters, blenders, and coffee makers. By having dedicated circuits for small appliances, the risk of overloading the electrical system and causing a fire is reduced. Now let us consider the location of outlets on these circuits as it pertains to NEC requirements. The NEC specifies that kitchen counter outlets must be served by at least 220 amp small appliance branch circuits. These outlets should be evenly distributed along the countertop to provide convenient access to power for various appliances. The code also allows for exceptions in certain situations, such as when counter space is limited or when appliances are permanently installed. In these cases, Alternative wiring methods may be permitted, provided they meet the safety requirements of the NEC. When installing branch circuits, it is essential to follow the guidelines outlined in the NEC and to use appropriate wiring methods and materials. This includes using the correct size conductors, properly grounding the circuits, and installing overcurrent protection devices to protect against short circuits and overloads. It is also important to ensure that all electrical work is performed by qualified and licensed electricians to minimize the risk of electrical hazards. In addition to small appliance branch circuits, there are other types of branch circuits used in residential and commercial buildings. These include general-purpose branch circuits, which apply power to lighting and general-use receptacles, and individual branch circuits, which supply power to a single appliance or piece of equipment. Each type of branch circuit has its own specific requirements and limitations, which must be followed to ensure safety and compliance. The proper design and installation of branch circuits are critical for the safe and reliable operation of an electrical system. By understanding the different types of branch circuits, their requirements, and the guidelines outlined in the NEC, electrical professionals can create electrical systems that meet the needs of building occupants while minimizing the risk of electrical hazards. Consider that the NEC is not a static document, and it is updated regularly to reflect changes in technology, safety standards, and industry practices. It is important for electrical professionals to stay informed about the latest revisions to the NEC and to incorporate these changes into their work. This includes attending training courses, reading industry publications, and participating in professional organizations. By staying up to date on the NEC, electrical professionals can ensure that they are providing the safest and most reliable electrical services possible. In conclusion, branch circuits are a fundamental component of an electrical system, and their proper design and installation are essential for safety and reliability. Small appliance branch circuits play a crucial role in providing power to kitchen appliances, and their requirements are outlined in the NEC. By understanding these requirements and following the guidelines outlined in the code, electrical professionals can create electrical systems that meet the needs of building occupants while minimizing the risk of electrical hazards. Let's further explore the specific requirements and considerations related to dining room outlets and their connection to appliance circuits. While the NEC does not mandate that dining room outlets be connected to appliance circuits, there are situations where it may be permitted or even advantageous. Understanding the factors that influence this decision is crucial for electrical professionals. Firstly, the NEC allows for dining room outlets to be connected to appliance circuits as an exception, particularly if the dining room is adjacent to the kitchen. This exception is intended to provide flexibility in situations where it may be more convenient or cost-effective to extend the appliance circuit to serve the dining room. However, it is important to ensure that the total load on the appliance circuit does not exceed its capacity. Secondly, the decision to connect dining room outlets to appliance circuits should be based on a careful assessment of the expected load in both the kitchen and the dining room. If the combined load is likely to exceed 80% of the circuit's rating for a sustained period, it is advisable to install a separate circuit for the dining room to avoid overloading. Thirdly, local electrical codes or interpretations may influence whether dining room outlets can be connected to appliance circuits. Some jurisdictions may have specific requirements or restrictions that must be followed. It is essential to consult with the local electrical inspector to understand their interpretation of the code and ensure compliance. If dining room outlets are connected to appliance circuits, it is important to ensure that the wiring and installation meet the requirements of the NEC. This includes using the correct size conductors, properly grounding the circuits, and installing ground fault circuit interrupter protection for outlets located near water sources. It is also important to label the outlets clearly to indicate that they are part of the appliance circuit. Consider that there are alternatives to connecting dining room outlets to appliance circuits. One option is to install a separate general-purpose circuit dedicated to the dining room. This provides greater flexibility and ensures that the dining room has sufficient power for its intended use. Another option is to install a multi-wire branch circuit, which shares a neutral conductor between two hot conductors. This can save on wiring costs while still providing adequate power for both the kitchen and the dining room. The choice of wiring method should be based on a careful evaluation of the load requirements, the layout of the building, and the local electrical codes. It is also important to consider the long-term needs of the building occupants. Will the dining room be used for occasional meals or for more frequent gatherings? Will there be a need for additional outlets or appliances in the future? By considering these factors, electrical professionals can design an electrical system that meets the current and future needs of the building occupants. Also understand that the proper design and installation of electrical systems are essential for safety and convenience. By carefully considering the load requirements, the local electrical codes, and the needs of the building occupants, electrical professionals can create electrical systems that are safe, reliable, and efficient.